Good morning and welcome to my presentation on atomic structure and bonding. My name's Emma and I'm just going to talk you through the slides that I've produced for you today. So first of all, I'm going to talk about atmospheric ions. So ions are an electrically charged particle that's produced by either the removal of electrons from a neutral atom that creates a positive ion, or by adding electrons to a neutral atom and that produces a negative ion. So these electrically conductive atoms of air were discovered by Richman in 1944. They naturally occur in our environment with some that are formed mainly in the upper atmospheric layers caused by ultraviolet radiation from the sun, and some that are formed by the lower atmospheric layers as a result of radioactive and cosmic rays. So you can just see like this little diagram here, you've got neutral atmospheric ions, galactic cosmic rays then knock the electron out of orbit, and it produces an electrically charged atmospheric ion. So that moves us on to the difference between ions and atoms. So you may be wondering what that difference is. So an atom consists of three subatomic components. You know, you've got your protons, your neutrons and your electrons. The nucleus contains the protons and the neutrons, whereas an ion is a charged particle, so it contains more electrons or protons or vice versa. So an atom gains an electron and becomes what's called an anion, so a negatively charged ion, or you can lose an electron and it becomes a positively charged ion. So that's called a cation. So ions form once a full outer shell has been created or completed. Moving on, we talk about how they join together to create a construction of two different atoms together. So bonding compounds, you've got ionic compounds and covalent compounds. Metal atoms lose electrons from their outer shell when they form an ion, and these electronically charged particles cause ionization of neutral molecules and atoms. And as a result, then you end up with a formation of an ion. Almost instantaneously, they combine with other molecules and create an ionic bond. So formed ions do have a complete full outer shell, and there's several different types and ways that bonding happens and occurs. The main things that we're going to talk about today are ionic, covalent, metallically, and secondary bonds as well. So the two on this side here are ionic and covalent. So we've got non-metal and metal on both sides. This side here with an ionic compound happens when a transfer of electrons happens. And also then you've got on the covalent compound, you've got a sharing of electrons. So you've got positive and negative charges and no charges and so on. So ionic bonds. Bonds sort of form between two ions via an exchange of electrons. So you've got the bond in which one or more electrons is removed from an atom and is attached to another atom. So this results in the positive or negative ion that are attracted to each other. So this sort of happens between metals and non-metals that have different levels of electronegativity. So they're good conducers and they have high boiling points. So compounds display from ionic bonds form ionic crystals in which ions of positive and negative charges are situated near each other. So you've got examples are sodium chlorine and potassium oxide. So you've got an example on this diagram here of sodium and chlorine. The sodium now carries a positive charge because it has more protons than electrons, and the chlorine now carries a negative charge. The attractive force between the ions hold them together, and this creates the ionic bond. If we talk about covalent bonds, on this sort of example here, you've just got like a simple unpaired valence electron here. So atom 1 non-metal, atom 2 non-metal or metalloid, and a covalent molecule there. So you've got a sharing of valence electrons. So the bonding occurs between non-metallic elements that have got similar electronegativity. They form by sharing a pair of electrons. So examples would be oxygen, carbon dioxide, H2O. They sit in an s and a p orbital, and that determines the bonding that happens. And a covalent bond forms when the bonded atoms have a lower total energy of the surrounding widely separated atoms. So there are different types of covalent bonding. As you can see on the diagram there, you've got single bonding, double bonding, triple bonding, polar bond, non-polar bond, and what I'm going to really cover off is coordinate covalent bonding. So the covalent bond is formed by two atoms that share a pair of electrons. You know, they've got in polar covalent bonds, such as bonding between hydrogen and oxygen, the electrons are not transferred from one atom to another as they are in an ionic bond. The atoms are held together because they are attracted to each other's nuclei, and a coordinate bond, that's also called a dative covalent bond, is a covalent bond in which both electrons originate from the same atom. So you know, for example, you know, if they both came from carbon. Let's talk about metallic bonds. So this is obviously, is sort of the name gives it away, the bond that's found between metal elements. They've got a very strong bonding power. The force of attraction between these free moving delocalized electrons and positive metal ions. So they've got usually got a really high boiling point, good conductors of electricity and heat. And examples of those are sort of aluminium, gold, and as you can see in this diagram here, it just gives you an idea of electrostatic attraction between the electrons and the metal ions. Just want to talk about secondary bonds. So you've got a section that branches off of primary bonds and secondary bonds. And so primary bonds are when we're talking about ionic bonds, covalent bonds, metallic bonds, and the secondary bonds are your hydrogen bonds and your dipole interactions and your dispersion bonds. Now these all form, they're categorized under the van der Waals forces. They're weaker in nature than primary bonds, and they form between the partially positive and charged hydrogen atom in one covalently bonded molecule and the partially negative charge of another covalent bonded molecule. So they're found in most materials and they're often overshadowed by the strength of the primary bonds. So the idea of covalent bonding can be traced back to Gilbert Lewis. He discovered the sharing of electron pairs between atoms in 1916, and he introduced the notion of the Lewis electron dot, or the Lewis dot structure, whichever you prefer, in which valence electrons, so the ones in the outer shell, are represented as dots around the atomic symbols, and pairs of electrons located between atoms represented covalent bonds. So you've got the crosses there in between as well. So as you can see on this example that I've drawn, one carbon atom with 4 cross electrons and 2 oxygen atoms with 6 dot electrons. So the oxygen atoms there, as you can see, have got 2 dots on each one, and 2 on that one, sorry, 6 even, and 6 on that one as well. So they're 2 shared groups of electrons there, and they each end up in the covalent bond there in the join of 2 crosses and 2 dots. So in total there's 16 valence electrons throughout the pi2 by bonding orbitals. So there's a full double bond between carbon and each oxygen atom. My next example that I've given you here is methane. So the carbon atom has a valence of 4 and is therefore surrounded by 8 electrons, which is known as the octet rule. 4 from the carbon itself and 4 from the hydrogen that's bonded to it. So as you can see there, you've got a dot and a cross, dot and a cross, dot and a cross, dot and a cross on there. So you've got your 4 hydrogen atoms and your carbon atom as well. So moving on, you've got a third example here of chlorine. So 2 chlorine atoms both achieve stable structures by sharing their single unpaired electron. The 2 chlorine atoms are joined by a covalent bond, and the reason that they stick together is because the shared pair of electrons are both attracted to the nucleus of both chlorine atoms. So each chlorine atom has a valence of 3. The final example I want to explain to you is hydrogen chloride. So hydrogen has a helium structure and the chlorine has an argon structure. So That makes them both non-metal. Non-metals don't have a tendency to lose electrons because they're relatively stable. So both the elements H and Cl, so hydrogen and chlorine, they share their electrons to complete their octet and make them stable. By sharing the 2 electrons where the shells touch, the hydrogen atom, it counts 2 electrons in its outer shell, and the chlorine atom counts 8 electrons in its outer shell. So the full outer shells with their electrons are now stable, and the HCl molecule will not react any further with either chlorine or hydrogen atoms.